Hello, everyone. I'm Julian, and today, I'm talking about 10 years of building open source standards. And I'll start with Parquet, go to Arrow, and end with OpenLineage, which is a natural conclusion to this talk. So it's organized in 3 chapters, and along the way, I'll talk about the story, how those things happen, and the lessons learned along the way for each part. So I'll start with the birth of Parquet. So this starts out a little bit about me. 15 years ago, I was at Yahoo, working with Apache Pig, and Apache Pig is kind of like less used project nowadays, and it's been mostly replaced with Spark as the better MapReduce as it was at the time. But that's the project where I got my first committership on an Apache project. I started as a user, moving to contributor, to committer, to PMC member, to eventually be PMC chair for a year. And so I've seen great experience through that path was to learn and understand how those different roles work, how open source works, and understand this notion of becoming part of the project, not just a user. Around that time, that's also when the Dremel paper was published, and I initially read it, which has been seminal to some of the things I've done later. So after that, I moved to Twitter. Like through this open source community, there was like a lot of people in Twitter, LinkedIn, Netflix, working on similar projects. And that was the context for the inception of Parquet. So at Twitter, there was Hadoop, and Hadoop would scale a lot, be able to store a lot of data or process a lot of data, but was high latency, right? So you would start a job, you would go get coffee, and then you would get the result, right? But it was pretty cheap. You can put a lot of data in it and figure things out later. Meanwhile, we also had Vertica, which is a data warehouse on-prem at the time, and that provides more interactive queries. And you can actually also store a lot of data, but it's not as scalable. It could not store as much data. It was more expensive. So there was always this tension of you would have a better experience querying data in Vertica, but you didn't have all the data that you had in Hadoop, right? So that was a constraint. So part of that thinking was, can we make Hadoop more like Vertica? And thinking about how Hadoop is a MapReduce framework on top of a distributed file system, while Vertica is a distributed query engine on top of a columnar storage, right? So some of that thinking of like, how do we get the best of both worlds, right? So one thing that was interesting at Twitter is we had this paper reading group. And so people would read papers, present to the group, and explain things. And I got to read the Vertica and C-Store, precursor to Vertica papers, the Dremel paper again, reading MonetDB, understand better the architecture of those MPP databases and how that works. And digging a bit into the columnar layout, what's the columnar layout? Well, if you have this table representation in our head, you have this bidimensional table with columns and rows, right? But when it's physically stored on disk or on storage, it is linear, right? You have to turn this 2-dimensional thing into a 1-dimensional list of bytes. And so row layout, you just put each value, each row one after the other, and so you interleave data of different types. When in columnar layout, you just put all the data for each column together, right? Which brings, if you're reading only a few columns, you can just read a lot less data because it's easy to quickly scan just that data. And it's also easier to encode and compress better that data. And so it has a lot of benefits on retrieving data from disk, from the storage layer, a lot faster than in a raw layout where it kind of assumes you retrieve everything before you do anything with it. So that led to the birth of Red Elm at the time. So a red elm is the tree, and at Twitter they named everything after birds, but birds live in trees. So I thought that would be a good name as well. And that was the intersection of implementing the algorithm in the Dremel paper, looking at the existing file formats that existed, like T files, RC files, CIF, TREDNI, which had good things and things that were missing, and so on. And looking at the schema systems we were using at Twitter, which were Thrift, which is similar to Arrow and Protobuf, and Pig, which had its own schema model. So combining all three things led to the birth of the design of Red Elm. And I got this first commit going in August in 2012. And Red Elm is an anagram, right? So actually the project was quite ambitious at the time. As a side project, I was doing mostly in the shuttle drive to and from the office, as Red Elm is an anagram of Dremel, and I was envisioning at the time how we are going to rebuild the entire thing. But also at the time, starting from the storage layer, I figured that I would not be able to, if I build my own proprietary file format, I would have to rebuild everything, integrate with everything. And it was like too big of a task for one person or even one team. So I started seeking for partners and contributors. So, this is a bit tongue-in-cheek tweeted at the time of implementing the algorithm on the Dremel paper. But that led to the connection with the Impala team at Cloudera, right? Because obviously this problem I was looking at, I was not the only one seeing it, right? So there were other people looking at how we make, Hadoop more like a database, and less like a, brute force scanning of data. So that led to the creation of Parquet. So from the Red Elm's side of things, where the columnar representation well integrated in Java ecosystem, looking at MapReduce and Pig and nested structures. On the Impala side, they were looking at building a SQL on Hadoop, as this category was called at the time. Now it's more like the lakehouse model. Having columnar representation, native code generation to be able to have a distributed query engine. So that sounds like a great thing, because it's like, oh, they're already working on the distributed query engine part. We just need to connect the dots and make things work better. So we agreed on joining forces. We merged design. I reworked a lot of my Java side of things. They implemented it on their native side of things, and that became Parquet. And we picked a name that would reflect more for being the bottom layer and the storage layer for the project instead of the whole thing. So that's how we created Parquet. And if we look quickly at the timeline, when we started from the announcement of Twitter and Cloudera collaborating, and it was not just one company, quickly several companies started being interested, like Criteo, which is an ad targeting company in Europe, added Hive support. Netflix adopted Parquet. That was a huge point in the timeline. Apache Drill adopted Parquet as the baseline for storage. And then it entered the Apache incubator, becoming part of the Apache Foundation, got integrated in Spark, became a top-level project, had the C++ implementation, and then it reached escape velocity. And in a few years, went on a trajectory that today it's integrated in all major warehouses. Everything supports Parquet. You can read Parquet from your Excel if you want. And so the lesson learned along the way of building Parquet, I'll stop in my story to talk a bit about that. And one important thing is every contributor is a stakeholder in the project, right? So you join and you're not just using the thing and just being a consumer. You become part of the decision-making process, right? You become a part of making the project a successful things, helping with adoption, providing input, being part of the decision-making and being part of this, right? And this is really important to an open source project like this, and establishing a standard and really making sure users, contributors become stakeholders. And there's a snowball effect to it, right? You see in Parquet, initially, it was just two companies, but even that is really important to show there's momentum. And especially as being Twitter, being vendor neutral and showing this is going to be neutral and not favoring anybody in the process, and quickly gaining momentum and moving fast. And open source comes in all shapes and sizes. The first thing, the most basic definition of open source is the code is available. but the code is available doesn't mean you can use it, right? That's where licenses are important. And you have various types of licenses. Apache license is very permissive. All you have to do is give credit when you're using that code. GPL is more restrictive. It's just if you build something on top of it, it has to also be open source and follow the same license. And then the project can have an open license, but still you have no control on the direction of the project. That's where governance comes in. And governance is like being clear of, can you become a committer? Can you even contribute to it? If you can contribute to it, do you have any say on the future of the project? Do you have any paths to become like a decision maker part of the project? That's where governance is important, and having a clearly stated how do people participate in the decision making process. Is there a voting mechanism and so on? And the last thing is you can have a governance without being part of a foundation. But then the foundation is the thing, like Apache Foundation or the Linux Foundation being the two big open source foundations, is what guarantees that the license of the project is never going to change, that the governance of the project is always going to follow some particular rules, and being an open project and inclusive and bring people in. So, any of those people may or may not follow those things. What's important is being upfront about it, and all shapes and sizes are fine, and it's just important to understand what's controlling the direction of the project. So second part is from Parquet to Arrow. So there was the beginning of conversation in the Parquet community that we also needed an in-memory columnar format. And as part of the discussion, it became clear that it awfully looked like the in-memory columnar format that the Apache Drill project had built. And the reason there's a need for this is like on disk is for fast retrieval, and in memory is for fast execution. So if you look at the MoneyDB paper, that's very seminal to this kind of thinking, and vectorization and how you take advantage of modern processor to process data better, having this in-memory columnar representation so you can take advantage of processing data much faster using SIMD instruction and these kind of things is available. So we kicked off with a group of people this initial consensus of Parquet as this fast disk retrieval and Arrow as this fast in-memory processing, vectorized execution, zero copy transfer. And through an initial group of people like came from the Parquet community and around it a little bit, created this Arrow project. So if we look at the timeline, we had this kickoff on requirements, like getting an initial group together, an initial spec together, establishing it as a top-level project in the Apache Foundation, spin off the Java code from the Apache Drill, and start the C++ implementation. And there's a similar motion. You see this timeline starts like at the end of my previous timeline when I stopped for Parquet. You can still grow in momentum. And it became the basis for Pandas, the new Pandas implementation, making it much faster, became integrated in Spark because the Pandas to Spark integration would be much faster, and so on. And nowadays, if we fast forward to today, you see major warehouses are also supporting Arrow as a better way to exchange data with like Python or other things people are using. And DuckDB is this kind of odd new thing that has been built on top of Arrow, right? So it's like SQLite for OLAP or local mode for your data warehouse. If big data is dead, your big data fits in memory now. Like machines got so much bigger. There are lots of processors. So it's funny to see we went to appliances to distributed computing on a lot of computers back to Buffy machine that can do a lot of parallelism and a lot of processing. So lesson learned along the way, right? So one is bootstrap the community with an initial spec, right? If we're pushing this snowball to get the snowball effect, you want to make sure the ball is as big as possible when you get started, right? If you like exponential curves, well, exponential curves at the beginning are insanely flat, and it takes a while to get to the inflection point. So if you want to build a standard, start like bring a bunch of influences and perspective in the initial spec and people to help pushing that and making sure you're going to have a lot of adoption initially, right? So that you can get this going faster. And then it's important to find like-minded people who will drive this vision, right? So you don't need to convince everyone at the beginning, right? So you always have the people who wait to see if a project is going to be successful before they adopt it. And then there's the people who understand that because they adapt it, because they're going to put their weight behind it, then it's going to be successful and they're going to benefit and everybody's going to benefit from the project, right? So you need to start with the visionaries, and you just need to find a few people, a few groups, a few companies or organizations or other projects that see the vision, agree with it, are aligned, and are going to help push it. And then you get the early adopters, people who are kind of like more easily see that vision and see the initial success of the project and are going to adopt it and grow the community, and eventually it becomes mainstream, right? In the end, the rest of the people get convinced because the initial early adopters see the benefit from it, right? So you just need to keep this going and start with the right subset of people who are going to contribute to build that vision. And really, it's about the connection we build along the way, right? I'm presenting this like there's like a plan, and we're kind of, if you do this, then you're going to be successful. But it's about the journey. It's not about the destination, right? The trick is we really enjoy collaborating and building those connections and getting people to work together and making it happen, right? This is an enjoyable project that makes the whole thing working. Like, people have sometimes told me like, oh, you're doing open source the right way, like meaning sometimes like it's the hard way, right? Because you include everyone, you do the thing. Yeah, but that's the way it works, and it's enjoyable to be able to collaborate with those like smart people along the way. So on that, I'm going to my like next logical step, right? Like talking about OpenLineage, and let's keep a slide. And then the main problem of thinking about what's the next thing, why do we need OpenLineage, right? If you look at the way people do data transformation and depend on each other, usually it works well inside of each team, and they have their own practices and they know how they do things, they know how things depend on each other. Usually there's lots of friction in between teams, because that's where like there's a lot of opacity. Where is this data coming from? Where it's going? Who's consuming it? I don't like not understanding dependencies beyond a certain bubble you live in. And that's where, you know, there's this Maslow's hierarchy of needs. Like, to reach happiness, first you need, you know, shelter, food, safety, and then, you know, you can think about like being happy, being the best version of yourself. There's something about data. A lot of the time you stay under the waterline, like you have your head underwater, and first the data needs to be available, it needs to be fresh, it needs to be correct, and then you can start building on top of it. And a lot of the time we spend too much time like, oh, just like the data is not available, it's not fresh, it's bad, I need to fix it. None of that, right? So it's really about how do we get to the next level and like get rid of those problems so everything's good. So that led to the inception of Marquez. So like being the architect for data platform at WeWork, one of the big missing pieces, in my opinion, in this data ecosystem was a place that we know about all the jobs, all the data set, all the things that existed and how they depend on each other, right? So we started Marquez at WeWork as part of the data platform, and same thing, you know, bringing in other opinions, like validating the use case. We want to make sure this is going to be something that's reusable, integrate in the ecosystem. You want this to be open source, so it integrates in the ecosystem, and you don't have to do everything yourself, or like integrating with everything and reinventing and reverse engineering everything to get lineage understand dependencies. And then led to the creation of DataKin, like focused on the data observability, data reliability aspect, and now part of Astronomer. And so before OpenLineage, we were Marquez, we're part of this ecosystem, and you have all those things that people can use to collect lineage, but they all have to understand the internals of all the data transformation layers that everybody's using. So it leads to this incredible complexity and duplication of effort. Like, everybody has to understand everything about everything to collect lineage. And so we're like, okay, we don't need to compete with everyone on doing this. Everybody needs that same layer. How do we expose lineage? How do we extract lineage? How do we understand how everything works? How do we make this piece, just that small piece, reusable for everyone and solve it as an industry, as an ecosystem all together? We get together and we solve it. So that led to the creation of OpenLineage, and we spun out of Marquez integration. We reached to a group of people, really taking a page out of the Arrow playbook on how we bootstrap the community, how we get enough weight behind this at the beginning so we can bootstrap this snowball effect and get things going. And it fits as like the spec and protocol layer, how we exchange lineage between all the producers of lineage and related metadata data quality metrics, right? Like schemas, column level lineage, like cost, all those metadata you can collect around this operational lineage and push it into all the metadata layers. Like here I'm focusing on the open source ones, but that works also for commercial ones as well. And so going a little faster, and then possibilities are endless. You can do governance, you can do compliance, you can focus on the privacy use cases, reliability use cases, banking regulation, a whole length of things. And so OpenLineage, same thing. We join the LFAI and data, which is a sub-foundation of the Linux Foundation, like very similar to the Apache Foundation in terms of having a neutral body that makes sure the project is going to always be neutral and always have a clear governance. And then there's a bunch of support of open source projects like Spark, Airflow, Great Expectation. And then like commercial solution also came in the game and became interested in being part of this. So Microsoft Purview is a big contributor and consumer of OpenLineage. There's also a Snowflake Labs implementation, and working with Menta, with a company focusing on lineage that supports also OpenLineage, and a bunch of other things, and growing same thing, like getting the same momentum and getting adoption because there's this need here. And so if I go and finish my talk with the lessons learned here, someone asked me, I was telling about it, I've done Parquet, I've helped like get Arrow off the ground and get this spec going and adopted. And I understand, we can just we're doing the same thing with OpenLineage. And they said, like, what makes you think you can do it again? Well, the trick is, it's not like you start a project and you have some mind trick and you convince everyone to use it, right? That's not how it works, right? You start with, there's this thing that everybody needs, right? How do we get this very focused, very single-minded project on that thing that everybody needs? We align everybody's incentives. Everybody benefits when this thing happens. We empower the community. We make sure everybody's involved and they become a stakeholder and they understand that they benefit, everybody benefits, and there's very like healthy life cycle happening. And then success happens, right? It starts with that. And I have this Stone Soup story. So the Stone Soup is a children's book story where people, like someone comes to a town square in a village, and they have a pot and they start stirring the pot and they put a stone at the bottom of the water. And then people ask, what are you doing? Well, I'm just making a stone soup. But you're welcome to add your own ingredients to it and make it better, right? So basically they're doing a soup at nothing, right? The stone doesn't bring anything to the hot water, but they're stirring the pot. They're making it available. They're creating this focal point, and people come with carrots, people come with leeks, with potatoes, make the soup better. And just because someone is stirring the pot and making it available and making it easy for everybody to contribute, then it happens, right? It's exactly what I'm doing with OpenLineage. I'm just stirring the pot, enabling everybody to contribute, being part of this, and making it happen. And really, it's all about aligning incentives and building a network effect. Sometimes people say, you're boiling the ocean, right? So that's not true, right? Because if I were like boiling the ocean of pushing a rock up a mountain, as I have more people, right, we just like linearly making it faster, right? Like we boil the ocean a little faster every time someone comes. It's not like that. It's not linear. It is exponential, because every time someone joins, then they convince other people, right? There's this network effect that every people that gets convinced that it's going are going to become like a visionary and seller for the others, like, and convince other people that this is happening. And the magic happens not when, the original people who work on the project convince everyone, but then when those people talk to each other and then convince other people, and there's really this network effect. And so to conclude, there's like those lessons learned. People are stakeholders, right? They're not just consumers. There's a snowball effect, right? They gain momentum. It gets faster as it gets faster. And open source is all shapes and sizes, and it's fine. You want to bootstrap this community to get the snowball going faster at the beginning. Collaborate with other visionaries and trailblazer. Enjoy the connection you build along the way. And find what everybody needs. Feel that needs, and it's going to be successful. And, stir the pot of the stone soup, align incentive, and this network effects is happening, and it's working. And that's it. On that, I would like to thank you